All right. Well, good morning, good afternoon, and good evening, everyone, depending on where you're joining us from today. And welcome to today's Exploring by the Seat of Your Pants event. My name is Joe Grabowski, and I will be your host for today. If it's your first time ever joining us, huge welcome. We're all about bringing science, adventure, exploration, and conservation live into classrooms across North America and beyond. So if you head over to exploringbytheseat.com, you can find 30, 40, even 50 live events a month that classrooms can join in and interact with scientists and explorers from all over the world. All right, well, we were so excited for today's event. Today's event is a real introduction, a real kickoff celebration. So many classrooms may remember that last year we spent some time with Hearts in the Ice live from Svalbard and learning all about climate change, citizen science. It was an absolute blast. So much fun. In fact, we thought, hey, let's do it again with the amazing team. So in 2019, 2020, Sunniva Sorby and Hilda Strom made history when they became the first women to overwinter in Svalbard solo. They spent 12 months at the remote trapper's cabin called Bumsabu, located 78 degrees north and 148 kilometers from the closest town of Longyearbyen in Svalbard. In fact, their closest neighbors were probably the polar bears that we're visiting from time to time. So climate change is not taking a break, so neither are they. From November to May 2021, they are headed back to Bumsabu with no running water or electricity, and they will be relying on wind and solar for their power. They've pulled together an amazing group of 10 global partners, and Hearts in the Ice is the bridge between science and global citizens to better understand climate change and why we all need to play a role. We can't just sit back, we have to be involved and hands-on. So they're going to continue to serve as citizen scientists as they build on their second year of collecting data. So let's head right now to Svalbard. We have the amazing Hilda and Sunniva joining us live. How are we doing, ladies?
We're doing great.
We're doing great. And this is amazing because it's the first time we actually get to be on a video call doing this with you, Joe, with no satellite disruption. So
and no polar bears outside.
That's right. That's right. Soon, though, you'll be back at the cabin and we'll get the voice action. We'll probably hear the wind whistling in the background during the blizzard. So, but it is great to have the two of you live on camera. And I mean, the classrooms are so excited to get to know you today. We've got classrooms tuning in from across North America. It's going to be a lot of fun.
Fantastic. Thank you.
All right. So I'm going to throw it your way. I'll let you take over for a little bit.
Okay. Yeah, we can do that and then start with the little video later. But Hilda, I'll let you take it away.
Yeah, sure. So this evening's event is about weather, and we are so lucky to have Siri Kalvig. I'm sure that Joe is going to do the introduction later, but she's an expert on weather. But we have also experienced a lot of weather the last year, and I've been living up here in Svalbard for many years, and we've seen so many changes. And changes up in the Arctic is happening so much faster than you guys are experiencing. So the climate is so different from just 10, 15 years ago. And that is in temperature rise, sea ice. And sea ice is important for seals and polar bears. We had a lot of polar bears around us last winter. We had a fairly cold winter last winter, but still it was above normal. It was warmer than it's supposed to be. And I just have to mention this. Last Thursday, less than a week ago, we had the warmest day in November on record here on Svalbard with 9.4 Celsius plus degrees. So it was raining, pouring rain all weekend, which is not supposed to be. And last year, a year ago, we had minus 15 up to these to that date, and also this coming month is going to be hopefully colder. And we are heading back to Bumsabu in 2 days. So weather has changed so much, and it's all due to climate change that Sid is going to talk a little bit more about, and also tell us the difference between weather and climate and what's the difference. But we see that the surroundings and all the animals around us are affected by this. We've seen it in the ocean and we see it on land. We see that reindeer this year is going to struggle a bit because the rain has made a sort of a solid ice layer on land, and we have less ice on sea, and that's not good for seals or everything that lives in the ocean, and also the polar bears.
And another one of our themes this month is technology. So weather and technology. And we'd like to really thank, so much of what we're doing is hosting, via satellite from Bamsebu, and we can't do that without partners. So Marlink is our education sponsor for this month. So we thank them hugely. And actually, technology. I mean, where would we be in 2020, understanding all the changes that are happening around the world without technology? And Hilda and I are going, like Joe said, far away, where very literally our neighbor is the polar bear. And so safety is a very big concern for us. And can you pass me that little, check this out. This is like a big, round dish. Doesn't weigh very much, but that's going to be our remote satellite dish. It's called the Thales Mission Link. And last year we were the first civilians to actually field test an MCD mission link in a Pelican case. So this is our lifeline to all of you when we make our satellite calls with this phone. That's how we're going to be calling you, Joe, from Bamsebu and all the schools. Via satellite. So it's absolutely a key for us to be able to connect both for safety and also for our entire Hearts in the Ice project is communication. We're also going to be using this thing right here. It's a cool DJI Indro Robotics infrared drone. And that's really important for what we're doing in terms of citizen science, because this drone flies in a pre-programmed pattern. And it measures over time, not just surface air temperature, but also photos of glacial sedimentary deposits over time. And with these images that are captured, over time, Eric from BCIT is able to take this and create 3D images of the changes over the season. So this is really a very important way to not just study our land and our sea ice, but also wildlife. There are opportunities to actually use drones to study both geography and wildlife over time. And then there's this unit back here, which is a Pelican case, and it's called I'm going to show you right here. It's a telemed kit. I don't know if you can see this. It's by Marlink. And we've had a really sick dog for the last few weeks. And this unit right here will enable Hilda and I to connect directly via video satellite to our doctor if anything's wrong. It's got a thermometer, blood pressure, stethoscope. So it's sort of like a doctor in a box. So we're definitely field testing some pretty out there equipment that we believe is not just important for us, but also important in terms of connecting the world when everybody's so remote. So that's us. And thanks for joining. And Joe, we're going to hand it back to you.
All right, excellent. So I know we had an intro video, but I got so excited with the luxury of having the two of you on camera. I went right to the two of you. You want me to pop up the video and give them a taste of a little bit of the weather and what to expect?
Yeah, actually we would, because you know what? Then they get to meet Etra.
Yeah, and it's just a couple of hours ago, so that they can see how dark it is too.
Perfect. Polar night coming in, and well, I'll just let the students experience a little bit of those kind of weather sounds. So here we go.
Hi everybody.
Hi everybody.
I'm Sinava.
And I'm Hilda.
And this is Etra. Etra, our 3-year-old Malamute. And we are standing in the town of Longyearbyen. 2,300 people live here, and there are actually more polar bears in the archipelago of Svalbard than there are humans. We are in the middle of the polar night right now. It's 24 hours of darkness, and that's when the sun officially dips more than 6 degrees below the horizon. And so we'll be in the polar night now for the next 3 months.
And we would like to thank Marlink.
We would like to thank Marlink, our education sponsor for technology and weather, this month's theme. So we're very happy to have them as our primary satellite communications partner.
And in 2 days from now, we are leaving for Bamsebu, from Longyearbyen to Bamsebu. It takes 9 hours with a boat, and we're going to be completely isolated, because in a few weeks from now, it's going to freeze over, and isolated until at least for 4 months. And we plan to stay in this little trapper's cabin until May. And This traverse cabin is 20 square meters, and that's approximately 215 square feet. No running water and no electricity. And we are going to serve as citizen science at Bamsebu, collecting data for researchers, 8 projects working on climate change. And regarding climate change and weather this month, last Thursday was November 12th, and we had plus 9.5 degrees Celsius, which is the highest temperature in record. And last year,
It is so different last year.
15 minus. So yeah, climate change is happening.
And we're seeing more and more extremes around the world, aren't we? Yeah. It's just, so that's what we're trying to do with Hearts in the Ice. We're trying to bring everybody into the conversation. So this month, as it's weather and technology, we are going to use a drone that will actually help us measure surface temperature over a period of time. Then we're also going to be using this really, really amazing kit right here from Marlink. It's called a telemed kit. And this will enable us to actually connect directly with our doctor via video satellite. In case something's wrong with you, in case something's wrong with me, or in case something is wrong with Ethna.
That's so cool. So we're gonna see them on the call, or we're actually gonna call in the call.
And we can't wait to be immersed in Bamsebu and then connect via satellite for the months to come. Thanks, everybody.
Thank you. Bye.
All right, very cool. I hope the propellers are on a little bit better when you go to fly the drone.
I forgot about that.
All right.
It's all fastened.
Very cool. Well, I'm going to tuck the two of you backstage temporarily, but don't go anywhere because we're going to need you for a little Q&A action in a little bit. All right. Okay, so I'm really excited to introduce our special guest today. We have Siri Kalvig joining us today. She began her career as a weather presenter at TV2 and went on to establish a leading global provider of weather intelligence, StormGeo. She leads Nysnø Climate Investments, which means freshly fallen snow in Norwegian. This is a state-owned company that focuses on climate technologies. She holds a Master of Science in Meteorology and a PhD in offshore wind technology, and she's founded several businesses with experience in finance and startup with environmental technology. So I'm going to bring Siri in live for us. Siri, how are you doing today?
I'm fine, and you?
Good, good. It's so great to have you joining us live today. We've got a great group of classrooms joining us, and we're excited to learn a little bit more about what you do.
Yeah, and I'm really excited about the whole thing you are doing, and I'm so impressed by Hilde and Susanne. And I feel warm and cozy in here. I'm from Stavanger, so it's dark outside and the rain is pouring down. But at least I'm safe and warm. So good luck to Hilde and Susanne when they are leaving Longyearbyen. Okay, so I will talk about weather and climate. While I was preparing for this presentation, I might now share the screen with you. Let me see, share screen. Okay, here we go. Then I found out I wanted to call the presentation Hearts in the Cloud, because it will be quite a lot about clouds when I go through my presentation now. But first of all, I want to start with something which I find very fascinating. So you should have a look at these pictures and try to guess what it is. It looks kind of strange. Here's another one. Here's another one. And now you might see what it is. So it's the very start of snow crystals. And these are real photos, which I think is really beautiful. This is another start of a snow crystal. And here you have a beautiful snowflake or snow crystal. So how do this crystal growth start? So I'm a meteorologist, but that's way back. But then when we learn about how snow is formed, we know we learn about ice nucleus, because pure water vapor does not condense so easily. So the clean air needs something to condense onto. It could be some dust, volcano ashes, some pollen in the air. So something smutty in the pure air, like a disturbance. You have to kickstart crystal growth. And once this is in place, then you can have beautiful crystal formation like this. And this is a real video of how snowflakes are forming. So in the very, very middle of a snow crystal, remember there's always something which are not so pure, something smutty. And for me, this is also turned into an analogy for innovation, and that we need to kickstart different processes in order to get them growing. And okay, here I took some old photos from when I were at the Longyearbyen, or this is not Longyearbyen, this is northeast from Svalbard, in the middle of the ice. And I've always been fascinated about the snow and ice, and that's also why I studied meteorology and cloud physics. And here I am at a research ship called Lanse, and I'm trying to figure out how the wind will be in different, the wind profile over different sea, or how the sea ice will affect the wind. So I think it was really nice to hear about all the technological equipment Hilda and Susanne had. And here I am with the Tetesond, which we launched 1,000 meters up in the air, and we measured the wind speed. So this was just to say that I feel a little bit connected with Longyearbyen and Svalbard, and I've been there several times since this. Okay, so why did I show you this ice crystal growth? Well, it's because it's extremely important for a lot of processes. So here you see the Earth, and you see white clouds, and you see also a white ice cover over the Arctic. So the highest clouds are formed from ice crystals, and also, of course, this sea ice you see here. And it is a way of regulating our climate. And that's why I call the company I'm working in now, Nysnø Climate Investment, for Nysnø, which literally means freshly fallen snow. Because currently now I'm working to fight global change by the use of technology. And that's the aspiration of the name. We need more snow. So let's talk a little bit more about why is snow so important for the climate. Well, it's all about the albedo. You might heard that name or term before, but it's the ability something have to reflect the light. So if we run this animation, you see when the sun rays hit the ice, it will get reflected. But when it gets hotter and hotter, the ice will melt, and then the dark sea will absorb the solar rays. And then it will be even more hotter, so you have an accelerated melting of ice and temperature increase. So this is one of the positive feedback loop in the climate, which we are very sensible to the result from, or it can really change or it will. It's about to change the climate dramatically. Here you see a picture of the atmosphere, and as I told you, the clouds in the very upper layer of the atmosphere are made from snow crystals. And then, of course, we have water droplets as well in the clouds. And let's dive a little bit into the atmosphere and talk a little bit about how it's constructed. So here you see the different layers of the atmosphere. So nearly all the clouds are in the troposphere, the lowest kilometer of the atmosphere. We have some clouds also in the stratosphere. And I will now continue to talk about different clouds that lives in the troposphere. So this cloud is a very common cloud. This is a cumulus cloud, and it comes in all different shapes. And mostly this cloud is made of water droplets. And here you see other type of cumulus clouds, and here's another one. But the very top here, I guess, is made of ice crystals. Then this is a very common type of cloud, but this is a very seldom cloud. And this is a very beautiful cloud, and it's one of the few clouds that are made of, it's in the stratosphere, very high up in the atmosphere, made of ice crystals. And it glows even if the sun is under the horizons. And here, that's a picture I took, or my daughter took, a very strange cloud. It's called Kelvin-Helmholtz cloud, or it's Kelvin-Helmholtz instability. So clouds can have different interesting shapes. Here's another cloud. It's a cumulus mammatus cloud. This is not a good picture. I took it myself. This is slightly better, or you see the cloud structure much better here. And this is really an amazing cloud called undulatus asperatus. And this is actually a new cloud. Well, I guess it's been, it always existed, but it just got a name, its own classification. And here's another cloud, which looks like a bird. So to look up in the sky and look for interesting shapes, I really recommend it. This cloud, it is not so very interesting maybe, but it's a typical front cloud. That's why I wanted to show it to you. And I wanted to explain to you how clouds are made. So we have three main areas of cloud development. So the cumulus cloud I showed you in the start is the convective type. So the sun heats the ground and the air rise and forms cumulus clouds. But then you have the frontal cloud type. That's more that's formed on intersection of hot air and cold air masses. And then you have orographic clouds, which are formed when air rises because of an obstacle like a big mountain. But you should just remember that all clouds are formed while air is rising, and we name the different clouds in different ways. Actually, it was a British scientist, Luke Howard, that named the clouds as early as in 1800 or 1803. And here you see some sketches from his days. And we are still using his terminology when it comes to clouds. And here I put a list of how we name clouds. And there is a little sketch on the right here. So there are three main classes: high, middle, and low. And then you have different subcategories. I like to rehearse those different names, and I really recommend you to study clouds and learn the name as well. It could be quite impressive to say that you have altocumulus or cumulus lenticularis, and then if you learn those names, you can describe the atmosphere very accurately. Okay, so I wanted also to talk a little bit about why it's so important to care for the atmosphere and the clouds, because clouds, they are visible, what you say, they make the invisible processes in the atmosphere visible. Because the atmosphere circulates in every living being, it's extremely important to us, as you know. But because of our use of fossil fuels, we are now changing the very composite of the atmosphere. And while we are doing this, we interfere with the heat balance. So we have short wave solar radiation coming in, and the heat is, or the Earth is heated up, and it send out a different type of radiation, which is more long wave. And the atmosphere will not let this out, but radiates it back. So then you have the result of more and more rising temperature. So this is the greenhouse effect. And this I'm talking about in YouTube video. It's I think it's called a TEDx Stavanger video, and there I talk about art and technological innovation and how we are influencing the atmosphere. So I would really appreciate if you wanted to have a look at this video. Not quite sure how long time I've used now. Is it possible to ask you, Joe? I have some couple of more slides, but I could also stop here.
Let me come back into the stream here. I think, Siri, I shared the link so they can check out the video if they like, but I think we should bring Sunniva and Hilda back in and meet some of our classrooms, because I know they're going to have questions for both groups.
Yeah.
All right. Awesome. Give me 1 second here. Let's bring in the rest of the team. There we go. All right. Great. Well, again, Siri, thank you for a great presentation. I am definitely going to start learning a little more detail about the clouds, because you're right. I think that would be a pretty good trivia trick to be able to kind of name some of the clouds instead of just calling them clouds.
Yeah. But Joe, how do I get, should I press escape to see you now? I only see my own.
Yeah, push escape and that'll end the full screen.
Okay. Wow.
And then you can take it right off if you hit the screen share again.
We'll take it off. No, I'm there.
All right, perfect. Good stuff. Well, let's start meeting some classrooms, because like I said, we have a great group. I'm going to start with some students in London, Ontario, because I know that with their schedule, their day or their afternoons or their morning, sorry, is coming to an end. So I'm going to bring them in. Mrs. Trempleasure's group, they are joining us in London. There they are. Let me turn on that mic. They have a slight delay, so hopefully Ms. Trempleasure will be able to come and join us and get the mic on. There she is. Ms. Trempleasure will be able to come and join us and get the mic on. There she is.
Okay, so we have, sorry, we're just about to kind of leave because of our schedule change, but one of the questions that we had was, what is it called when you study clouds? Like, what is the science actually called? And then what was the rest of the question? Why did you end up deciding to focus especially on clouds? So I guess this is for Siri mostly.
Yeah. So if you want to study clouds, then I recommend study meteorology, which is part of geophysics. I also used to work as a cloud observer, because that's also something you can work at or work with, but then more like an assistant to a meteorologist. Yes.
All right, very cool. Let me bring the feedback in there. Okay, let's head to another spot now. Let's go down to the US. We've got Chicago, Illinois. Miss Knight's group is hanging out with us. Let me bring them live into the call here. There we go. How we doing, Chicago?
Right here. Hello. Hello. Such thing as a tornado of snow.
We asked it one more time. Really loud.
Okay, I think I heard that. Was he asking, was there such a thing as a tornado of snow?
Yes.
Wow. Well, I think a tornado, it's all about a lot of wind, and I think there might be at least some hail together with tornadoes, but a tornado only with snow, I don't think that exists, because you need the tornadoes, at least the powerful tornado will be located where there is quite high temperatures. But interesting question.
All right, I've got a question here that just came in from YouTube, so we're kind of sticking on the theme of clouds, and Bronwyn is wondering if different clouds reflect how much pollution is in the air or the atmosphere.
Yes, many people say that, oh, look at this beautiful sunset, and no, but it's all about pollution. And as I started, my very start of the presentation was about how small dust particles create nice clouds or nice ice crystals. So yes, we could have a nicer sunset and maybe a little bit nicer clouds when there is a little bit more particles in the atmosphere. But I would not say that you should still admire clouds and not think about pollution.
All right, fair enough. Let's take a little trip now. Let's go to Toronto. Let's go to Toronto, Ontario. We've got some grade 5, 6s hanging out with us. Let me bring them into the call here. Mr. Hergott's group. How are we doing, Toronto?
You guys have any questions?
Yeah. How did people originally define the difference between the clouds? I mean, why did they decide to call them like cumulus clouds? Like, how did
so stratocumulus, alto, nimbus.
How did they choose which ones to be called?
Yeah, why they gave them different name is because we need to describe them so we can understand the different physics and how the atmosphere acts. Because if you see cumulonimbus incus cloud, you could say, oh wow, now maybe it will be hail. Or when you see some cirrus clouds forming, you could say there will soon be snow. And so this was when meteorology or weather forecasting developed as a science. We needed to have cloud observers all over the globe to report how the atmosphere looks. Yes, and why it was so. Cirrus is a Latin name and means like a feather, and then you have stratus is layer, and cumulus is evolving. So it's Latin names, which I believe you that speak English will also recognize a little bit, and it makes maybe sense to you.
All right. And so I do want to say that to the classrooms that we can also ask some questions about Hilda and Sunniva heading out to Bamsebu shortly and their experience from last year. In fact, we have one right here in the chat that I'm going to start off with. So this is, you were there for a year already. Now that you've had some time home and you're heading back, what are you looking forward to most about getting back out to the trapping cabin?
Oh, that's a good question.
That is a good one. We came back in September. We were at Bamsebu for a full year, as you just said, Joe, and we came back to a very changed world, a very heavy world. And now we're going back, and it was not an easy decision to make for us to go back, because it means we're leaving our family and friends again. But it felt really important for us to go back there and continue with the climate change conversation. And it's just been busy. There's been a lot, like our cell phones beep all the time, and there's meetings and things going on. So I personally, I'm looking forward to being in that place in our natural setting that is Bamsebu, and just being in that perfect, complete stillness with all our projects, each other, etc., and our mission. I'm just looking forward to actually landing there and being disconnected to get connected.
And I think to me, it's all of that too, absolutely. And it's also living very simple. I mean, we need to chop our wood, we need to find our water, we need to get up every morning to fire that hut or the stove to get warmth. We have to actually physically do stuff to survive and be immersed by the nature. Now we're coming, it's already polar night up here, which we talked about in the video, and Northern Light, see if we have any polar bears. We know already that we have 3 2-year-old polar bears that just was left by their mom this spring. So that's going to be very exciting to see how they act around our hut. And hopefully they will understand that they should keep their distance. And we have some reindeers that we're looking forward to see again. So just be in the nature, be a part of something that's so much bigger than us is something that I really look forward to again.
All right, very cool. Let's jump to another group now. We are going to head to Mr. Greenfield's group. They are joining us from Freehold, New Jersey. Let's bring them into the call here. How are we doing, Freehold?
Good, good. Question, if I share my screen, can my kids ask directly or will that not work?
We can give it a try. It works sometimes. It depends on if your microphone's really good at canceling out background. So why don't we see what happens?
I'll give it a quick try.
Okay, I see the screen share. I've got it in.
All right. So my question is going to come from Liana. Liana, do you want to ask your question about the snow?
Okay, can I say my post out loud?
Yeah, they can hear you. Go ahead.
Okay. How can you predict when the snow is coming?
Because it's so dark.
Is it for me, the question, maybe? Yes?
Yeah, I think so. They're curious about, with it being so dark, polar winter, how can you use the clouds? How can you predict the snow is coming?
Yes. So it's all about technology these days. So even if it's dark, we see the clouds from satellites. And also we have mathematical models. And that's a tool for forecasting the weather. But to be a good meteorologist or a weather forecast, we also need people to go out and observe the weather. And of course, the weather forecast, all the observations are much better when there is light. So it is a challenge also in weather to do good weather forecast when there are a polar night. But we have radars and satellites which doesn't care so much about the darkness.
All right,
weather,
very cool.
Did I say weather bears? No, I thought I said radars and weather satellite.
Yeah,
that's what I meant to say. Okay, I said that. Okay, sorry.
Hey, Joe, I just wanted to pop off of something Siri said earlier about starting off her career, if I caught that directly, by observing clouds. And I know in the chat box, a few people have been asking, and you mentioned it also, Siri, that there is NASA has an app, and it's called the Globe Observer. It's free. You can all download it. Hilda and I are citizen scientists, and so we're collecting data. We're not Siri. We are just citizens like all of you on the call, and we're collecting data for the people like Siri who are studying the changes out there. And thanks for putting that up there. And so we're actually collecting cloud observations from Bamsebu from the ground up, because there are 2 very special cloud types up here that they think do have an impact on climate change. So I just wanted to put that out there to spark the curiosity.
And it's so much fun.
Yeah, I really glad you also mentioned it, because this is something we all should try to do. I also have it downloaded on my mobile phone. It takes a little while to get used to it, but it's really nice to be a citizen scientist. Yes.
Yeah, and then we all can make a contribution to people like you, Siri, and all the scientists that are studying how it impacts the climate, which is so interesting.
All right, very cool. Love citizen science action. And I mean, those phones, they're so powerful. To think that computers used to fill entire rooms with not even a fraction of the power. It's pretty amazing what we have right in our pockets. All right, let's take another little trip here. Let's go to Mr. Kite's group. They're hanging out in Kingston. Let's bring them in live. There they are. Hey, Kingston.
Hello.
So how cold will it be in the Arctic compared to, say, here in Ontario?
Ooh, that's a good question.
What's the temperature there right now?
How cold is it?
Probably around 5 degrees, maybe.
Celsius.
Maybe a bit colder.
Yeah. So I grew up in Montreal, and I left British Columbia to come up to Svalbard. And I can tell you that this woman right here for the last 25 years has been living in, I think, one of the coldest places on the planet. It is going to be colder based on where you are, because we're in a higher latitude. And so the higher you go, the colder it gets. What was the coldest temperature last year?
34. But then we have the Gulf Stream, which actually warms it up a little bit. So even though we are as remote as and far up as Sunniva says, it is not that cold, but 34 minus. Well, and if you
plus the wind chill.
Yeah, and if you are living in a very small old trapper's cabin from 1930, which is no insulation, or it's not tight, so it blows a little bit through, then it's extremely cold.
I misspoke. We're not in the coldest place on the planet. That's in coldest recorded temperatures in East Antarctica. But hi, is that City your daughter?
Yes, this is Lily.
Hi, welcome.
She just came home from her dance class.
Oh,
now we're home alone. Yes.
Very cool.
That's kids all over the world, or all over. Yeah.
That's right. I just brought in another class. This is a grade 5 class, I believe, in Calgary, Alberta. How are we doing, grade 5s?
Okay, stand up, please.
What are you doing the cabin during polar night?
Say again?
What are you gonna do in the cabin during polar night?
What we were doing?
What are we going to do in the cabin during polar night?
Yeah.
Yes.
Wow.
We,
you know what? Do we have bands here? We are living in a really small space, as you know. It's you're in Calgary, so you're on metric. It's 20 square meters, really, really tiny. And we work there, we play there, we write there, we read, we work out, we sleep. We process our data from our citizen science that we're collecting. So it's our little lab. We have very little space to put all of our equipment. So we're super organized.
But we have the biggest backyard in the world. I mean, we have the whole nature around us and no neighbors, just polar bears and reindeers, and 140 kilometers to Longyearbyen. So we haven't seen people. Well, we didn't see people in 5-6 months, but we are busy.
And I'm going to be honest, because I have to be honest, because the polar night is, as you know, it's 24 hours of darkness. That means when I normally get up in the morning and, open the blinds, in this case, it's opening the wooden shutters, it's still dark out there. And that really impacts you mentally, physically. And I got, last year, I was sleepy for 3 months. I felt like I had this cloud. Siri, maybe you can help me with this. I felt like I had a cloud hanging over my head for 3 months until the sun came back in February, and it was really difficult. So having a routine, and Hilda is much more used to it than I am, having a routine and staying active was super helpful.
I remember a video you sent while we were doing the live events of the first time that the sun kind of nicked the horizon, and just hearing the two of you talking about how exciting it was to greet the sun and see the sun after so long in darkness. I can imagine it was a pretty exciting time.
It just pierces you. We'll never forget that.
Yeah.
So Mrs. Brasseau's group is hanging out with us in Chatham, Ontario, and they sent in some great questions via the chat, and they're some technology ones. So I'm going to toss them your way. So the first, we'll get them both in. So one is, how often are you going to be sending the drone out to collect data? And then they're wondering if the weather ever causes problems with your satellite connection.
Oh.
Yeah. You want to take one of those?
I can take one of those. So the weather, I don't know if it's just something we think, but Joe, you know this from last year, that we were cut off quite often when the weather was bad. So in some way, I think all this going on with snow and a lot of wind and probably big, huge cloud city makes our satellite connection a little fragile. So sometimes we were thrown out, sometimes more than others. But on a clear blue sky, when we had northern light and just blue sky, it was easier. So yes, it was. We were affected, but most, I think, we inside the hut and outside the hut were more affected by the weather than our communication. Yeah.
And the drone, this guy here, I took the propellers off in case they'd fly off again. But we have to wait for the right wind and weather conditions to fly this drone, because it's not that heavy. And this battery right here, this is the battery. And you know, it's an amazing drone from Indro Robotics, and it's we're able to fly it in the dark because it has an infrared camera, so it can pick up wildlife from afar. So we fly it a couple of times a week. Actually, that's usually what we will do in a pre-programmed flight, and that's kind of been the case last year. We'll do that again, but it is, I think we flew it in minus 28 degrees Celsius. So it's just the battery gets cold and it comes back. It returns to home when the battery's running low, and then we swap the battery out and it goes out to finish its flight. So, and it's a very fun thing to do. We can also do 360 around Bamsebu and make some selfies with the drone.
It has a purpose for the scientists, but it also allow us to do some fun pictures for our private use and for our communication out to you guys.
And one last thing on drones, this company who makes this, they have just announced that they're in Canada. They're out of Salt Spring Island in British Columbia. They are the first company to be authorized by Transport Canada to actually make drone deliveries. So they're going to be delivering medical supplies and such to remote communities in a time of COVID. And I asked if they could deliver a cappuccino and a couple of cinnamon rolls to heat them up, but they said no.
Well, it was worth a shot. You never know, right? You got to ask.
Worth a try.
All right, very cool. I look forward to seeing some of those selfies, those 360 selfies as the journey gets underway. So we've had a few classrooms who have had to duck out because their periods have ended, but we do still have more with us. So I think we can probably squeeze in another question or two. So if you're in your classroom and you've got a question, give me a wave at the camera and that'll be my signal to come back and visit your crew. Okay, let's start off. There we go. There are grade 5-6s.
Hi. So I had a couple questions. Can we ask, do you want me to ask the polar bear question or the storm question? Both? Okay.
All the questions.
So so there's a movie called The Day After Tomorrow, right? I'll come down here so you can see me. And Day After Tomorrow, do you know the film, Siri?
Yeah, I know it. I've seen it and I love it. Yes.
Yeah, it's a great film, right? So the question is that massive whole planet storm possible?
No, no, I don't think so. And I think they are totally exaggerating in this film. Nevertheless, I think it's important because they squeeze maybe 200 or maybe thousands years of climate change into 2 days.
Yeah. Right. Okay. I thought so. And also, would the atmosphere be able to hold that much precipitation or that much of a cloud Like, or is there a certain balance of how much can actually be in the sky at any given time before it ends up falling down?
Yeah, luckily there is everything is about keeping the balance. So there will be different processes to balance it out and prevent this of happening. But we can have, of course, very, very terrible storms, and they can be even more dangerous and more powerful in a changing climate, but not as we see in the day after tomorrow.
All right.
Are you there, Joe? Huh. Something happened. He's coming down.
Yeah, my mouse is too sensitive, so my fingertip touched it and it kicked me out. But I'm back now. All right, very cool. I think I saw some other waving in a classroom. Let me see. Oh, there we go. Let's go back to our group in Calgary.
How does clouds stick together instead of falling on the ground into a puddle of water? And how does snowflakes stay together?
Yeah, how does snowflakes stay together? It's a good question. So should I just answer it, Joe?
Yeah, absolutely.
Yeah, well, yeah, I think they just cling together, but they are like sticky together, and it's but they form individually and they grow into each other. I actually have to say I don't have a very good answer. It was a very good question. I haven't thought of it that way.
Yeah. Well, that's the beauty of what we can do today is that, a little homework for the classrooms, we can have them go out and Google and see what kind of properties it takes for those snowflakes to stay together.
Yeah, that's a very good question. Sometimes when you see, when you can take a picture of snowflakes, I can do it with my iPhone. I have an extra lens I can put on. And then I was waiting for very single snow crystals to fall. So sometimes you see these fat, big snowflakes. Otherwise, other times you see just nearly one single one falling down. So it all depends on the temperature and the humidity. And the best pictures you will find if you find a single snowflake.
All right. So I want to share a couple things before we wrap up for today. The first is this website. If you want to dig a little bit deeper into some of the events that we have coming up live, some of the education events over the coming months, you can head over there to exploringbytheseat.com and you can find it with the / Hitty for Hearts in the Ice. I also want to share that if you dig a little bit deeper into the site, you can find a page we have set up for weather. In fact, I'm going to share my screen really quickly here, and I'm going to share that there where students can kind of dive a little bit deeper into some great curriculum material. So give me just 1 second here. That should be sharing now. Okay. So if you visit the site here, you can find, of course, our proud sponsor joining us, Marlink. But then as you go down, you can find a story map. And if you dig through this story map, you can find all sorts of great information about weather and climate, resources, videos. If you go down a little bit further, you can find some of the citizen science projects that Hilda and Sunniva are working on. So you can find to download some of those apps and do some of them yourself. And of course, I want to highlight some more events coming up this month. So on the 24th, we'll be live with Tom Matthews, who is just on Everest with a team of explorers, and they installed the highest weather station in the world. So that should be a lot of fun. And then our friend, Canadian explorer George Krunis, is going to join on the 24th at noon. And Hilda and Sunniva will join us again, and he'll talk about some extreme weather. And George has been all over the world checking out some wild weather events. So I'm going to come back from that screen share now. And first of all, I want to say, Siri, a huge shout out. Thank you so much for joining us today and sharing with us a little bit of the work you do and why we should pay a little more attention when we look up at the clouds passing overhead. And Hilda and Sunniva, I absolutely can't wait. This is such a great intro today to kick things off. Next time we connect, I think you'll be a little bit further north, a little bit removed from Longyearbyen. Yeah, we'll have the satellite phones out again. So we hope classrooms, the ones joining in today and more, are following along on this journey. And as we cover so many amazing topics, and really the topic of our time, which is climate change.
Thank you, Joe.
So
and I just, there is a question in the sidebar that I just want to address because it's so close to home for Hilda and I and Siri too, is the topic of citizen science. And the question was, what's the most important thing our students can do to combat climate change? We can't fight the trends that are happening, but what we can do is better understand them. And so that's entirely what our project Hearts in the Ice is about. Is Hilda and I have spent, close to 50 years in the polar regions as explorers and citizen scientists and doing all sorts of different things, and seen a lot of change. And we're curious people. So what we want to do, the answer to your question is stay curious, get engaged, and maybe you just start with the Hearts in the Ice project. Join these calls, share the ones that are coming up, because all the topics we're focusing on have something to do with climate change. And the more information we have, the more equipped we are to better understand how we personally can maybe slow down the reversal of change.
Yeah, and knowledge change behavior. We think if we know how we harm the world, we will take better care of it and be conscious users, thoughtful users. So become citizen scientists. It's so much fun. You can all make a contribution. So join us in that.
All right. So I have the website up for heartsintheice.com as well. So you can check out some more about the upcoming expedition to the north. So one thing I'd like to do is shout out all the YouTube classrooms. We had great questions coming in via YouTube. Thank you to all the groups who tuned in there. A shout out to all our camera classrooms. In fact, the ones that are still left, I'm going to bring in and put you on the spot. Can we get a big goodbye and a big shout out? Hey, so great to see everybody. Thank you for joining us this week for the first event. We hope to see you next week. We've got some exciting events, and it's going to be just a great wrap of 2020 and 2021 starting. We're so excited. Again, Siri, thank you so much for a great topic and talk today. And Hilda, always great to see you. It's going to be a little different coming up, but I always look forward to little video clips that you shoot for us before every event. So yeah, looking forward to that.
Siri, tusen hjertelig takk.
Tusen hjertelig takk, Siri.
Det var veldig kjekt. Thank you all.
You are the host with the most, and thank you very, very much.
All right. Well, everybody enjoy the rest of your week. Any questions, you can always send them our way and we can pass them on. But thank you, everybody. Enjoy your week, and hopefully we see you next week as well.
Bye.
Bye.